What's going on, all my healthcare brothers and sisters? I hope you are having a wonderful day. We're going to finish off the ATI TEAS version 7 mathematics portion of the exam by discussing measurements and data. Let's get started. So as always, we begin by looking at our objectives that we're going to see on this portion of the exam. For measurement and data, there's going to be a total of 16 items that are scored out of the 34 questions that are on the exam. So in order to pass this portion, you need to interpret information from charts, tables, and graphs, evaluate the information of data sets, charts, tables, and graphs using statistics, relationships between two variables, calculate geometric circumference, and convert between standard and metric systems. So the ATI TEAS is going to use a variety of graphical displays that you must have the ability to interpret information from charts, tables, and graphs. So we're going to take a look at what some of these tables and charts and graphs are going to look like. We're going to start with Cartesian coordinate graphs. So these graphs will have a pair of perpendicular lines called axes that intersect at a point called the origin. The axes are used to locate points on that graph. Next, we have scatter plots. A scatter plot is a graph that shows a relationship between two variables. The variables are plotted as points on the graph, and the relationship between the variables are as shown. Next, we have line graphs. Line graphs tend to be what everybody finds most appealing because it's something we use all the time. Line graphs are a graph that shows information that changes over time, right? As you can see in the example, we have ups, we have downs, we have big ups, right? That is how information changes over time. We also have pie charts. These are also heavily used. And a pie chart is a graph that is broken down into sectors, and each sector represents a portion of a whole, right? So maybe you have a percentage of people that completed their education, a percentage of people that attended a meeting and where they were from demographically. Taking that information, breaking it down, and representing the information as a whole, with each particular section of the pie showing that particular sector. And then lastly, we have bar graphs. Bar graphs are also very huge. And bar graphs are used as a diagram in which numerical values of variables are represented by height or length by rectangles, right? So if you take a look at here, we're looking at worldwide number of electric cars. And over time, electric cars seem to become more and more popular, right? It started off very low in 2012, and then all the way up until 2019, which is the most current data that was shown, it's very high, right? There's a good percentage of people who are purchasing electric cars versus traditional or classic cars. Next, we have how to interpret graphs and charts. They're going to ask you to interpret them when you're taking a look at some of these charts. So we're going to begin by looking at the title. So the title of a graph or table will give you an idea of what specifically the data is all about, right? In this particular case, we're looking at worldwide number of cars. Next, we have axes. So we have an x-axis, which is our horizontal axis, and a y-axis that will tell us specifically what the variables are that we're measuring, right? We have the bottom, we're measuring by years, and the top, we're measuring by units, right? We also have data. So data is just that information as a whole that is being plotted on the graph or listed on a table. Next, we have scale. The scale is the range of values that are being used. In this particular case, we're looking at years, right? Our scale usually follows our horizontal axis. So particularly when it comes to scale, we're looking at how long, how much, right? We're looking at years in this particular case. Then we have units. So units usually follow our y-axis. And the units are the measurements that are being used, right? We're measuring specifically a portion of people that are now purchasing and owning electric cars. Next, we have trend. So trend is really the most important thing when it comes to a graph is how are we trending, right? As a business, how are we trending on that graph? If we're trending up, that means we're doing really well, right? When we're looking at like total purchases. Whereas if we're trending down, we were doing really well, and now our numbers are going down. We need to fix that, right? We need to figure out what's going on. And then lastly, we have quadrant. You see this more in your traditional line graphs, right? Or your traditional charts where you're plotting numbers. Usually there's a quadrant, and usually it's broken down into 4 because there's usually an X. So you have like quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So now we're going to move on to evaluating the information of data sets, charts, tables, and graphs. So now we know how to read them and interpret them as well as what they are. How do we evaluate them? So we start by looking at mean, median, and mode. So what does that mean? So the mean is the average of a set of numbers. In order to find the mean, we have to add up all of the numbers together and then divide those numbers by the number of numbers that are in that set, right? So for example, we have a set of numbers here, 12, 13, 14, and 15. So what we do is we're going to add all of these numbers together. So if we add all these numbers together, we are going to get 70, right? But 70 is not the answer that we're looking for. We're looking for the mean. So we need to divide that number that we get when we added all these numbers together with the total numbers that are found within that set. So we have 1, 2, 3, 4, 5. So right, we have a total of 5 numbers within that set. So we're going to divide 70 by 5, and that is going to give us 14. So in this particular set of numbers, 14 is our mean. In addition to mean, we also have to figure out median. And the median is that middle number that falls within that set. In order to find this number, you need to arrange the numbers from least to greatest. Remember, we talked about this in our previous video, is that when we're looking to put these numbers in order, we need to start with least. So if we have any negative numbers, the higher the negative number, the least it is, all the way up to our positive numbers, right? The higher the positive number, the higher the number is. So in this particular case, we got lucky. Our numbers were already in that order, right? So now we're just looking for that middle number. So we know from our previous equation that we have 5 numbers, right? So we need to look for that number that falls in the third place. That is our exact middle number. And in this case, that is going to be 14. So we figured out our mean and our median. All we have left now is mode. So the mode is the number that occurs most often in a set of numbers. In order to find this, again, we have to rearrange the numbers from least to greatest and find the number that occurs most often. So for example, I had to change it up a little bit. We have 12, 12, 13, 14, 15, and 16. So thankfully, it's already in that arrangement that we need it to be in. So now we're just looking at the number that occurs the most. Well, as you can see for this example, 12 occurs twice. All the other numbers occur once. So the mode of this particular equation is going to be 12. An additional number that you're most likely going to have to find in the measurement and data portion of this exam is range. So range is measured by finding the difference between the largest and smallest number in a data set. So to find the range, we're going to subtract the smallest value from the largest value. So in this case, we have those same set of numbers, 12, 13, 14, 15, and 16. So as we know, our smallest number is 12, and our largest number is 16. So we simply just subtract 16 from 12, and that gives us the number 4. So in this particular set of numbers, we know that our range is equal to 4. So sometimes you're going to have to be looking at ranges when it comes to a correlation of data. So data ranges can be classified by how many points are plotted on a graph. So for example, this can include standard deviation, symmetry, number of peaks, and skewness. So we start with standard deviation. So this describes how the spread of data is from the mean. So we know that the mean is that number that falls in the middle, right? So how is that data spread out from that mean? A low standard deviation means that most of the data is really close to the mean, right? So if you're looking at your data points and everything kind of falls kind of close to that middle number, then we know we have a low standard deviation. It's not really deviating much, right? However, we can have a high standard deviation, and that means that our data is completely spread out when it comes to the mean. So a lot of business and scientist people will use this information to evaluate what's happening with a product or with an experiment to figure out, is there a low standard deviation or is there a high standard deviation, and how do we fix that, right? Next, we have symmetry. So symmetry occurs when data is equally distributed on either side of a line or a point. So if you take a look at what the example I have here, you can see that if you were to plot this out, it is equal on the upper quadrant and the lower quadrant, as well as in the other sides, right? So maybe this is quadrant 1, 2, 3, 4. If we were to measure them based on where they fall on this line, they are going to be equal on either side. Then we have number of peaks, and this occurs when data has multiple local maxima or minima, right? So data can either be unimodal, meaning that there's one peak or bell-shaped, or it can be bimodal, meaning that there's two peaks. If you actually take a look at this, it's actually interesting, is that this looks like an arterial line, right? This looks like the information that we would be getting from our arterial line. And as you can see, we have multiple numbers of peaks, right? So that would be classified as multimodal. However, just for this example, they usually want you to know unimodal as well as bimodal. And then lastly, we have skewness. So skewness occurs when data is not equally distributed on either side of a line or point. So data can be right skewed. Most of the data is on the right side of the graph. Or left skewed, meaning that most of the data is on the left side of the graph. Or it could be uniform, meaning that the data is equally spread out amongst the graph. So how do we interpret trends on a graph or table? So we really need to look at these particular topics in order to identify trends and graphs on tables. So to begin with, we look at type of trend. So when looking at type of trends, they're either going to be linear, meaning a line, they're going to be exponential, or they're going to be quadratic. If we're looking at the direction of a trend, we're looking at the direction the trend is going. It could be positive, it could be increasing, it could be negative, it could be decreasing, or it could just be flat, right? There's no change happening whatsoever. And then lastly, we have rate of change. And with rate of change, this is the amount that the trend is increasing or decreasing by. We talked about rate of change a little bit before in our previous mathematics video, so make sure that you go over there and check that out. In the meantime, we're going to take a look at an example. So we're going to take a look at this graph. We have a couple data points that we need to plot. So we have 0, 0, 0, negative 0.25, 0, negative 0.5, and 0, negative 0.75. So we need to figure out where these particular plots sit on our graph first, right? So we always go from left to right and up and down. That is the order that we follow. So our first number is 0, 0, meaning that we are really at the midpoint. So I'm going to put a little circle right here. Next we have 0, negative 25. So we're not going right to left, right? Because our first number is 0, so we're just going to go down to negative 0.25. That's our next point. Then we have 0, negative 0.5. Again, not going left and right, we're just going down. 0, 0.5, right? And then we have 0, negative 0.75. Again, same thing, not going left to right, we're just going down, 0.5. This is how we plot out our data. So the type of trend that we're seeing here, right, is linear. It is a line that goes up and down. The direction of the trend is negative. So if you look at it, based on our plots, as we were going down this line. So we have a negative trend with these particular numbers that we plotted on our graph. The rate of change is 0.25 because every time we went down 0.25 based on the data that was provided. Okay. There's also something else outside of this where we could have outliers. So sometimes it falls beautifully in this particular situation and sometimes it doesn't. Outliers is a data point that is far from the other data points on a set. So let's say, for example, we're going to go to our next problem. We have an example of 12, 13, 14, 15, and 16. We graph that on our chart, and it looks like it's going up, right? We have a positive numbers. It's going from 12 to 13 to 14 to 15 to 16. However, maybe the question is going to say we have this one point that is 50. So out of everything, we've got, okay, it's slowly going up, and then all of a sudden we have this 50 out of nowhere. That 50 is going to be considered your outlier. So whenever you have questions that are asking for what is the outlier of these numbers, it's usually the number that doesn't correlate with the others, right? The other ones are increasing by 1, and then all of a sudden you have this other number that doesn't increase by 1, or doesn't follow that rate of change. That is what your outlier will be. And lastly, for this section, we're going to have probability. So probability is the chance that an event will occur. Probability can be expressed as a fraction, a decimal, or a percentage, depending on what you're looking at. And the equation you're going to look at is P, parentheses event, is going to be equal to, parentheses, the number of desired outcomes divided by the total number of outcomes. So for example, when we're looking at probability of a dice, what is the chance of you rolling a 6 on a dice that is 1 out of 6? Well, the probability is going to be 1 out of 6, right? Because there's a 1 out of 6 chance that you were going to roll a dice. You can also further break this down into a decimal, right? If that's what it's asking. So 0.166, so on and so forth. Depending on what it asks you to round up to, maybe it says round up to the nearest thousandths place, then you would be looking at like 0.167 or something along those lines. But that is how you are going to determine probability. What are the chances that out of the total number of outcomes that could occur, that I am going to perform this one particular outcome that I desire? So next we're going to move on to relationships between two variables. And usually we're looking at dependent and independent variables. So a dependent variable is the outcome of an experiment or a value that is being measured. And typically that variable is going to be dependent on something else, right? It has to have something else in order for that variable to make sense. An independent variable is one that does not depend on another, right? It doesn't need anybody else. It is independent. So this can be classified as cause, the independent variable, and the effect, the dependent variable. So for example, in an experiment where we see different amounts of light affect the growth of plants, the dependent variable would be the height of the plant, right? And the independent variable would be the amount of light. No matter what we do with that light, the light is always going to be the same, right? Whereas our dependent variable, in order for that plant to grow, it has to be dependent on the light. So let's talk about correlation. You're going to use this all the time with your practice as well as business. It's used constantly. So we're looking at correlation and covariance, and that is the statistical measurement that describes the relationship between two variables. There are 3 types of correlations that you need to know: positive, negative, and no correlation at all. So a positive correlation means that one variable increases and another variable also increases. So as we take a look down here in our chart, our positive, we see that that line is going into a positive direction, right? It's going up instead of down. Whereas with our negative correlation, that means that one variable increases and the other variable decreases, right? So with our negative correlation, you see how that those variables are going down. It's going into a negative direction. That's not what we want to see. And then we have no correlation at all. So if you take a look at this one, there is absolutely no correlation taking place here. There's no relationship between any of these variables. An example of positive correlation in real life can be as the temperature outside increases, so does the ice cream sales, right? We have an increase and an increase. So temperature increases, ice cream sales increase. An example of a negative correlation is that as the price of gas increases, I think we've been experiencing that lately, right? The number of miles driven per week decreases, right? So we have an increase and a decrease. That is our negative correlation. And then with our no correlation, the number of hours of sleep per night has no correlation with the grade on a test, right? It's been proven, there's been a lot of scientific data behind it. There is not a magic number of hours for you to sleep in order to get a better grade on the test. If you study and sleep appropriately for whatever is, right for you, then most likely you're setting yourself up to get a better grade. However, it's never guaranteed. You may also need to compare and contrast direct and inverse relationships. So a direct relationship or direct variation is a straight line relationship in which the dependent variable increases as the independent variable increases, right? We have increase, increase. So for example, y is equal to mx. Whereas with an inverse relationship, we have more of a curved line relationship in which the dependent variable decreases as the independent variable increases. And you usually typically see that as y is equal to m over x. All right, now we're going to start measuring some geometric quantities, right? And we're going to start with perimeter and circumference. So the perimeter is the distance around a two-dimensional shape, right? We're not looking at 3 dimensions yet, just two-dimensional shapes. The formula for a perimeter is P is equal to S plus S plus S, right? So we're just adding up all of the sides. So we would add up this side, this side, this side, this side, and that would give us our perimeter. But sometimes we have to find the perimeter of a complex shape, as we see here, this kind of diamond-looking shape. So again, we add up all the lengths of each side together. So we would add up this side, here, 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 and here. And that would give us the perimeter of these odd-looking shapes. Then we have circumference. So that's something that's a little bit different that usually correlates with our circles, right? It's very difficult. There's no sides, right? It's just a circle, just a circle. So the formula for circumference is C is equal to pi times the diameter. So we need to know the diameter of a circle, and we're going to multiply that by pi. And usually pi is 3.14. So perimeter is really easy. Now we're going to start talking about area. How do we figure out an area of a two-dimensional shape? So we do this by different kinds of formulas depending on what the area looks like. So in order to find the area of a rectangle, we have to use the formula length times width. So we need to figure out what is the length times the width of a particular rectangular shape. Whereas with a triangle, this one's a little bit more complicated. So in order for us to figure out the area of a triangle, we have 1/2 times BH, where B stands for the length of the base and H stands for the height of the triangle. So another common two-dimensional shapes that you're going to see on your ATIs regarding area is going to be circle, parallelogram, and trapezoid. So starting with the circle, the area of a circle is A is equal to pi times radius squared. So your diameter is going to be the total length of your circle, whereas your radius is going to be about half of your circle. So you're going to want to know half of your circle in order to determine what the area is going to be for a circle. Next we have parallelogram, and this one uses A is equal to H times B, where H stands for height and B stands for the base. So just kind of like your triangle, with a parallelogram, it's just H times B, right? Whereas with the other one, you're dividing it by 2. And then lastly, we have trapezoid. So this is a fancy one that we have to figure out. So again, we have that 1/2 times H, where H stands for height, right? But with this particular shape, with the trapezoid, we have 2 different sizes of a base, right? With our parallelogram, the top base is going to be equal to the bottom base, right? Whereas this one is going to be very different. So you have base 1, right? And you have base 2. So you're going to need to know the measurements of the top of the trapezoid as well as the bottom of the trapezoid in order to determine what the area is going to be. So now we're going to move on to the more complicated things, and that's volume. So before we were looking at two-dimensional shapes. Now for volume, we're going to be looking at the amount of a three-dimensional shape and what it takes up, right? So it's three-dimensional. What is the volume inside that three-dimensional shape? So we start with our rectangular prism. So in order to consider volume for this prism, we have to times length by width by height, where L, right, is going to be our length, W is going to be our width, and H is going to be our height. Next, we have our triangular prism. So this one is almost just as close, right? Except we're adding something additional, we're adding length. So now we have base times height times length, right? And we're going to divide that by 2. You will also need to know how to measure our cylinder as well as a rectangular pyramid, okay? So we have a rectangular prism and we have a rectangular pyramid. So starting with a cylinder, for this one in particular, you're going to need to know pi times radius squared plus height, right? So you're going to need to know the radius of one of these ends, and you're also going to need to know the height of your cylinder, or it should technically. It's just because it's on the side. There we go. The height of your cylinder. And then lastly, with the rectangular pyramid, we are going to now divide this by 3, right? So we have 1/3 times the length, the width, and the height. And we're going to divide it by 3. Because remember, when we're looking at volume, we're looking at cubic area versus looking at the other ones that we discussed before. And then lastly, we have cones. So in order for us to figure out the volume of a cone, we use this equation. We use 1/3 pi r squared height, right? So we know that our height is the height of the cone. We know that our radius is going to be half of our circle at the bottom. And we're going to use pi because that is what we use when we're trying to determine area and volume of a particular circle or a 3-dimensional shape. And in this case, again, we're going to use 1/3 because we're looking at cubic volume versus what we discussed before. Lastly, we're going to take a closer look at converting between standard and metric systems. So in order for us to be able to convert, we have to know what they are, right? So we start with the standard system because in the United States, that is what we are accustomed to. So the most common units for length in the United States is inches, feet, yards, and miles. The most common units for capacity would be things like teaspoons, tablespoons, cups, pints, quarts, and gallons. And the most common units for weight would be ounces and pounds. So how do we convert? Well, we use dimensional analysis, which we're going to discuss next. So we use dimensional analysis to convert units. So it's really a 4-step process. Step 1 is we have to determine what we are converting. So in this case, we are converting length from inches to feet, right? That's what we are trying to figure out in this particular equation that we have. Next, we need to determine the relationship between those units. In this case, we know that 12 inches is equal to 1 foot. Third, we need to set up our equation, right? So we're trying to figure out how many feet we have in 12 inches. So we have 12 inches is equal to x feet. We just have to determine what our x stands for. So our last step is we solve for the unknown unit. So in this case, x is equal to 12 divided by 12 feet, or x is equal to 1 foot. The same process can be used to convert between units found within the standard system. So taking a closer look at the metric system, this is the system that is used in many other countries, and this is how they measure length, capacity, and weight. So the most common units for length would be things like millimeters, centimeters, meters, and kilometers. The most common units for capacity would be milliliters or liters, and the most common units for weight is grams and kilograms. Do you notice how there is a common theme? With length, the base unit is meters. With capacity, the base unit is liters, and with weight, the base unit is grams. So let's take a closer look at what this looks like on a scale so that we can determine how we're going to convert metric measurements. So I like to use the mnemonic, King Henry doesn't usually drink cold milk, right? So this is how we break down our metric measurements. So we have kilo, we have hecto, deca, we have our units. Remember we talked about grams, liters, and meters. We have deci, centi, and milli, right? So the metric system is based on the powers of tens. This means that each unit is 10 times larger or smaller than the one before or after it. So for example, 1 meter is 10 times larger than 1 decimeter, right? We can see that based on our calculations down here at the bottom. This means that to convert from a larger number to a smaller unit, you will need to move the decimal point to the left, right? So for example, if we want to convert from centimeters to meters, you have to move the decimal 2 points to the left. So let's say we have an equation of 100 centimeters. In order for us to determine what the meters is, then we're going to move our decimal place over. So our decimal place is usually here, and we want to know what the meters is. You see here we have meters, so we're going to move it over to the meters column. So based on our calculations now, we have 0.1 meters is equal to 100 centimeters. You're going to use this again and again as you're looking at equations. Let's do another one. So let's say we need to figure out what 0.001 meters is. So what I typically do is I place my 1 in my meters column and then I add my zeros, right? So we know it's 0.001 meters. But we need to figure out that conversion to millimeters. So we know that our millimeters is down here at the end. So we are going to move our decimal over to millimeters, right? So 1, 2, 3, 4, 5, 6, right? So we move it at the end of our millimeters and we just add zeros. So now we have 1,000 millimeters. So we know that 0.001 meters is equal to 1,000 millimeters. I hope that that was easily understandable. If you have any additional questions, make sure that you ask them. I would love to do more practice questions with these to help further understanding of the metric system. So while all of this seems great, you might be asking yourself, really truly, what do I need to know for the exam in regards to converting between standard and metric systems? There's so many different kinds of conversions. What are the most common ones you're going to see? Well, the common ones you're going to see are listed here below. You've got kilograms to pounds, inches to centimeters, meters to feet, ounces to grams, and then miles to kilometers, right? So for example, 1 gallon is typically equal to 3.8 liters. What I will tell you is that you truly just need to memorize a lot of these different conversions, particularly these ones. These would be the ones that I would know for the exam to help you pass. But in general, when you get into the healthcare field, we primarily use the metric system. We don't really use pounds. You're more than welcome to enter it. However, when we're looking at like medications and things like that, we're not looking at pounds, we're looking at kilograms. So particularly for ATI-TEAS, know these, but just know that once you get into your chosen career, that measurements are going to look very different. I hope that this information was helpful in understanding what you're going to see on the ATI-TEAS version of measurements and data. As always, if you have any questions, feel free to leave them down below. I love answering your questions. Head over to www.nursecheung.com where there is a ton of additional resources available to you. And as always, I will see you in the next video. Bye.